Okay, we are continuing on with hypothesis testing for population means in OLI Mod 26. I'm going to take a look at a Learn by Doing activity that's on page 173. It's actually in a pop-out, so what you're going to see is a link called Using Technology with Data to Run a Hypothesis Test. The question is, do undergraduates sleep less than graduate students? A study conducted a student conducted a study of sleep habits at a large state university. His hypothesis is that undergraduates will party more and sleep less than graduate students. He surveyed random samples of 75 undergraduate students and 50 graduate students. Subjects reported the hours they slept in a typical night. So the first thing I want to do is remind us that even though the question that this researcher is posing is about a very large population of seemingly all undergraduate students and all graduate students, because this study is being collected from data from one large state university, we really can't apply it at random to that larger population without really thinking about maybe other confounding factors that could be involved, how populations might vary from one state university to the other, or from one university to another. So just something for us to keep in mind. All right, so while you're in OLI, you'll see that this data is in there, but I went ahead and loaded this data into StatCrunch for us. Before we look at the data, though, we can go ahead and do step one of our hypothesis testing, which is to lay out our null and our alternate hypotheses. So please pause your video, see if you can come up with those statements, and then check back in. Okay, I went ahead and assigned undergraduate students to be population 1 and graduate students to be population 2, just because that's the order they came to us in our setup here. Null hypothesis, setting our baseline, setting those two means equal to each other, and then in my alternate hypothesis, giving the change that we're looking for, that the mean hours of sleep for the undergraduates will be less than that of the graduate students. Okay, remember that you're always keeping nearby the hypothesis test grading rubric to help guide us through those 4 steps. So we are now on to step 2, where we need to take a look at our data. And for population means, that means we need to figure out our mean and our standard deviation. And now that we have 2 populations, we need to do that from each population. So let's go ahead and get this data set loaded. I will click there. I think if we just search OLI Mod 26, that gives us to us. So here is our sleep study data. To gather up our sample statistics, we will choose our stat function, summary stats. By columns, we need to get this information for both of our samples. Although we could scroll down to see how many pieces of data we have, let's just go ahead and get that in our results screen here. We know that will be important. We also need the mean and the standard deviation for each one of those data sets. And compute. So there are our values. I'm going to go ahead and write that over here. So undergraduates is my population 1. So that sample size will be N1, and that's 75. My sample mean, X1 bar, let's do 6.19, round to 2 decimal places here, and then standard deviation S1, 1.05. For our population of graduate students, N2 is 50, sample mean X2 bar 6.42, and our sample standard deviation S2 is going to be 1.03. Since we know that going forward, our two populations will be essentially put together using subtraction, let's go ahead and remind ourselves up here, our null hypothesis says that mu1 minus mu2 will equal 0, and our alternate hypothesis says that mu1 minus mu2 will be less than 0. And taking a look at what's going on in our sample, we need to look at x1 bar minus x2 bar, which turns out to be negative 0.23. Okay, what else do we need for step 2? We need to confirm that we have random and independent samples here. We're told that they're random, and there's no mention that they're related anyway, so we'll go ahead and assume that they are independent. And both of our sample sizes, N1 and N2, are greater than 30. So we are good to go with the requirements for our distribution of x1 bar minus x2 bar values to be normal, but since we don't have any population standard deviation to describe it, we're going to go ahead and use the t-distribution instead. We know the center of that distribution, the mu of all the x1 bar minus x2 bars, is at the difference in population means, mu1 minus mu2, and HO told us that that value is 0. Our sample value of negative 0.23 is going to be to the left of center, just because it's a number line, and of course negative 23 is less than 0. So here's the picture of our sampling distribution. So this is moving on to step 3. Our picture is complete. What we're going to need our p-value and our test statistic to help us decide is this value of negative 0.23 just a little bit to the left of 0 in a fairly common spot, or is it very far off to the left? So let's take a look. Our p-value is the probability that our sample difference, our x1 bar minus x2 bar, is less than or equal to negative 0.23 under the condition that mu1 minus mu2 is equal to 0. Or we could have written under the condition that mu1 equals mu2. Either way is perfectly fine, no worries. All right, we're going to go and use our t-stats function in StatCrunch to get both our p-value and our test statistic. So let's head on over there. Close that up. Stat, we're picking t-stats. We're picking to sample. We could pick with summary and enter the summary stat data that we got, but we can also just pick with data in this case. So that's kind of nice. Let's just do that. Let me bring the screen in a little more so you can see the whole screen. Okay, so sample 1 comes from population 1, which is our undergraduates. Sample 2 comes from population 2, which is our graduates. This pool variances, we're going to leave that non-checked. We would check here if we had some reason to believe that the population standard deviations are equal, but we don't, so we're not going to worry about that. Our null hypothesis, of course, is that mu1 minus mu2 is equal to 0, but our alternate hypothesis is that that difference is less than 0. We're going to set that up, click compute, and here is what we need to know. So there's that sample difference of minus 0.23 that we calculated earlier. And here's the results we need. So we've got a p-value of 0.1106. So remember, this is under the condition that these two groups have the same amount of average sleep. Our sample results would happen about 11% of the time, which is fairly often. So this is telling us that our sample results are not unusual at all. And what also backs that up for us is this test statistic. We are only 1.23 standard deviations to the left of the mean. So we're maybe somewhere about right there for our test statistic. We can see that both of these things are leading us to the conclusion that when HO is true, we have a perfectly reasonable result, not unusual in any way. So this would lead us to not reject our null hypothesis, which then means we do not support our alternate hypothesis. Okay, so that's the end of step 3. All that's left to do is our final if then therefore conclusion. Please pause your video and see if you can come up with that on your own. All right, this is what I've got. If the mean hours slept per night is the same for undergraduate students, then our sample results are likely. Therefore, our data does not support undergraduates getting less sleep. It is absolutely true that in our sample, the sleep for undergraduates, that average amount, 6.19, was less than the average amount for the graduates, 6.42. But what this hypothesis test has shown us is that it's not that much variation to lead us to believe that there's a difference in those population values. It is simply the variation that we expect to see from sample to sample. The other thing that we were supposed to do here was to take a look at the confidence interval and see how those things go together. So before we do that, I want us to think about what's going to be in the interval. So let's remember here that our data led us to not reject our null hypothesis. I don't know why my pen won't work here. Okay, here we go. So we are not rejecting our null hypothesis HO. And while that doesn't mean we're supporting HO, it does mean that we're not rejecting this idea that the difference could be 0. And if we're not rejecting it, then this value of 0 should be in our confidence interval. And if we're going to have the value of 0 in our confidence interval, well, that means that our left-hand endpoint would have to be something negative, and our right-hand endpoint would have to be something positive so that 0 is contained in that interval. So let's go over. Let's make our confidence interval. Remember, we can just go to the options screen because it happens in the same function here. Instead of hypothesis testing, we will click to construct that confidence interval, click compute, and there we go. So we see that our confidence interval, our left-hand endpoint is negative 0.609, and then the right-hand endpoint is 0.14 3. Okay, so at this left-hand endpoint, mu1 minus mu2 is equal to negative 0.609. This means that the mean amount of sleep is larger for group 2. It's larger for the graduates, and it is larger by an amount of about, little more than a half an hour there, by 0.6. On the other hand, on our right-hand endpoint, mu1 minus mu2 is equal to 0.143. So this now tells us that mu1 is larger than mu2 by an amount of 0.143. So now the mean amount of sleep for undergraduates is bigger by a little over a tenth of an hour, so not very much. But so again, right, this confidence interval is showing us that we don't support either group getting more or less sleep than the other. Part of our interval estimate has graduates getting more sleep. The other part of our estimate has the undergraduates getting more sleep. So no way for us to conclude that either group gets more sleep than the other.